Today we are going to learn about advanced customization of Matplotlib histograms. We'll explore how to apply advanced techniques for creating professional-grade histograms using Matplotlib, enhancing your data visualization skills. Welcome to our session on advanced customization of Matplotlib histograms. In this video, we'll explore the importance of customizing histograms to enhance your data visualizations for professional presentations. Whether you're looking to delve deeper into the data with detailed bin sizes or use color maps to convey data density, the techniques we cover will equip you with the skills needed to create compelling and insightful visualizations. We'll dive into Matplotlib, one of the most powerful Python libraries for data visualization, and explore advanced features that will elevate your presentations. The first step in customizing your histogram is understanding and adjusting bin sizes and counts. Bins are the building blocks of histograms, and their sizes can significantly impact the clarity and detail of your data analysis. By customizing bin sizes, you can either highlight subtle variations in your data or provide a broader overview depending on your analytical needs. To adjust bin counts in Matplotlib, use the bins parameter in the hist function, which allows you to define the number of bins or specific bin edges. Choosing the right bin size is crucial. Too few bins might obscure patterns, while too many may introduce noise. We'll walk through practical examples to see how different bin sizes can transform the insights gleaned from the same dataset, helping you make informed decisions about the best approach for your particular analysis. Color maps are a powerful tool in Matplotlib for representing data density in histograms. By applying a gradient of colors, you can convey more information about the distribution of your data at a glance. This technique enhances the interpretability of complex datasets by allowing viewers to quickly identify areas of high and low density. When choosing a color map, consider the context of your data and the message you wish to convey. Matplotlib offers a wide range of predefined color maps, accessible through the map parameter. Whether you're working with heat maps, population density, or financial data, selecting the right color map can significantly impact your visualization's effectiveness. We'll explore how to apply color maps to histograms and discuss best practices for maintaining visual clarity and avoiding misleading representations.
Annotations and labels are crucial for the clarity and effectiveness of your histograms. By adding annotations, you can highlight key data points, provide additional context, or explain patterns that are not immediately obvious. In Matplotlib, annotations can be added using the annotate function, which allows you to specify the text, position, and style of your annotations. Proper labeling of axes and data points is also essential for guiding the viewer through your data story. We'll demonstrate how to effectively add annotations and labels that enhance your histogram's readability and make your insights more accessible to your audience. Through practical examples, we'll illustrate how strategic annotations can transform a standard histogram into a powerful communication tool.
One of the advanced features of Matplotlib is the ability to incorporate multiple datasets into a single histogram. This technique is particularly useful for comparative analysis, allowing you to visually compare different data distributions side by side. However, overlaying multiple datasets can lead to cluttered visuals if not done carefully. To maintain clarity, consider using different colors or patterns to distinguish each dataset. Additionally, tweaking transparency levels with the alpha parameter can help overlay histograms without obscuring the data. We'll explore several techniques for effectively incorporating multiple datasets into your histograms, ensuring that each dataset remains distinct and the overall visualization remains clear and informative. Through practical examples, you'll learn how to apply these techniques to enhance your data comparisons.
Advanced styling techniques with line and fill properties can significantly enhance the aesthetics of your histograms. In Matplotlib, you can customize line styles using parameters like line style, line width, and color to make your histograms more visually appealing. Similarly, fill properties can be adjusted using the fill and alpha parameters, allowing you to add or modify the color and transparency of histogram bars. While styling is important for creating professional-grade visualizations, it's essential to balance aesthetics with clarity, ensuring that your visualizations remain easy to interpret. We'll cover practical tips for applying these styling techniques, demonstrating how subtle changes in line and fill properties can have a profound impact on the overall presentation of your data. Grid lines and tick marks are vital for enhancing the readability of your histograms. They provide reference points that help viewers interpret the data more accurately. In Matplotlib, grid lines can be added using the grid function, which allows you to control their visibility, style, and placement. Customizing tick marks on the axes further aids data interpretation by ensuring that labels are relevant and informative. Best practices include aligning tick marks with significant data points and avoiding overcrowding, which can detract from readability. We'll demonstrate how to customize grid lines and ticks to improve your histogram's overall clarity, providing practical examples that highlight the impact of these subtle yet powerful enhancements.
When preparing histograms for publication, ensuring high resolution is crucial for maintaining the quality and professionalism of your visualizations. In Matplotlib, you can specify the resolution of your output using the p parameter in the savefig function. Common file formats for publication include PNG, PDF, and SVG, each offering different benefits depending on your needs. It's important to consider compatibility with your intended publication platform and ensure that your histogram retains clarity and detail when printed or displayed. We'll walk through the process of exporting high-resolution histograms, highlighting key considerations and tips for achieving professional-grade output that meets publication standards.
While customizing histograms offers numerous benefits, it's important to be aware of common pitfalls that can undermine your visualizations. One of the most frequent issues is overcrowding, which occurs when too many elements are added, making the histogram difficult to interpret. Another pitfall is inaccurate data representation, which can happen if bins are not chosen appropriately or if color maps are misleading. Balancing aesthetics with clarity is key to avoiding these issues. We'll discuss common mistakes to watch out for and provide practical tips for successful customization, ensuring that your histograms effectively communicate the intended insights without compromising on quality or accuracy. As we conclude our session on advanced customization of Matplotlib histograms, let's recap some of the key techniques we've covered. From customizing bin sizes to using color maps, annotations, and incorporating multiple datasets, each technique plays a crucial role in enhancing your data visualizations. Remember, mastering these skills requires practice and experimentation. We encourage you to explore additional resources and continue building on the foundations we've laid today. As you apply these techniques in your work, you'll find that custom histograms become powerful tools for communicating complex data insights effectively. Thank you for joining us, and we look forward to seeing the exceptional visualizations you'll create.